Assalamu alaikum. This is Tayyaba Arif along with my group members Nimra Sajid, Huri Afsar, Javeria Wadood and Arid Awan from BS Chemistry from Fatma Jinnah Women University, and we are going to discuss the applications of nanotechnology in industries and sports. Nanotechnology is a branch of research that has gained much momentum in the recent years due to its wide applications of its principles and products. Within the niche of the sports, nanotechnology has proven to be very useful and has potential to improve a broad range of aspects of sports and industries. Here are the table of contents which we are going to discuss in the next few minutes. That we are going to discuss its application in sports, space and science, automobile and aerospace. So first I am going to discuss the applications of nanotechnology in sport industry. The degree of competitiveness in sports has been remarkably impacted by nanotechnology. Like any other innovative idea in material science, nanotechnology offers a number of advantages and immense potential to improve sporting equipment, making athletes more safer and comfortable. Nanotechnology have widely been applied in sports engineering such as tennis, baseball bats, badminton rackets, hockey sticks, racing bicycles, and golf balls. This may greatly change the present situation of sports and promote the advance of athletic sports, creating a lot of opportunity for the increase of the record of athletic sports. The applications of nanotechnology research ranges from fields such as disease prevention and treatments to advance and improve electronic devices. And so here the question arises that why we are using nanotechnology in sports equipment. It's because it offers a number of advantages, like it will reduce friction, enhance durability, enhance strength to weight ratio, improves resiliency, wear resistance, will reduce weight, make sports equipment lighter, and it will increase the hardness. Therefore, we are using nanomaterials in sports equipment. So let's discuss the game of tennis. The game of tennis is a prime example of how nanotechnology is having an interesting impact on sports equipment. According to the present research, equipment producer Wilson has been able to create tennis rackets that are twice as stable conventional rackets and up to 22% more powerful. This increase in the racket's performance capabilities can lead to big speed increase with what is already an extremely fast-paced game. In addition to the racket research, Wilson is also conducting research to find innovative ways to improve the tennis balls and that are using today. This research has allowed them to design the balls that hold their bounce much longer than is seen in the balls that are currently available in the markets. This is accomplished by bonding the microscopic balls of butyl rubber, that is a polymer, with the clay particles. This mixture is then applied to the inner layer of the balls that will create an airtight but still more flexible boundary that keeps the gas inside the tennis much longer. So here is the visual explanation of the result of how the airtight boundary is found. That is shown in the figure. As you can see, the ordinary tennis ball and the tennis ball with the nanocomposite gas barrier. Due to this, the gas in the ball will remain for much longer time, and this is basically the layering of the nanocomposite, that is the butyl rubber, that is bonded with the clay particles. Now moving to the sport of the golf. Nanomaterial like carbon nanotubes, fullerene, silica nanoparticles, nanoclays, carbon nanofibers, nanonickel are in the equipment use of the golf to invoke the benefits like potency, repellent power, enlarged stiffness, and reduced weight. The sport of the golf is also impacted by nanotechnology in a similar way as of the tennis. Breakthrough in the production of lighter yet stronger composite material has greatly impacted the design of the clubs. For example, Wilson is using a nanocomposite to replace the titanium crown used on its current golf clubs. The result of this is that it will lower the weight and center of gravity of the clubs and will increase the power and accuracy potential of the club. In addition to this, the stronger material used to produce the shafts used on golf clubs will render them more reliable and increase their service life. Golf balls have also reaped benefits of advances in nanotechnology, and the ability to control the protection of material on the molecular level has enabled the companies to develop a ball that does not suffer from having an uneven spin. This allows a ball that flies along a much straighter path. One of the biggest and the most universal problem in the sports world is that of smelly gym clothes and sports equipment. Sport equipment is traditionally one of the best breeding grounds for the bacteria and fungi that cause infections, odor, itchiness, sores, and smelly feet. When nanoparticles are developed that can mesh with the cotton, plastic, and nylon material in shoes, pairs, jerseys, helmets, socks, or other pieces of sports equipment. This is accomplished by making nanosilver particles that typically measures around 25 nanometer. What nanosilver particles can do that they will suppress respiration and vessel metabolism of electron transfer system and transport of the substrate in microbial cell membrane. This process inhibits the multiplication and growth of bacteria and fungi, therefore leading to much cleaner and better smelling equipment. Now let's discuss cycling. When it comes to professional cycling, every second counts toward victory. Changes have been done in manufacturing of bicycles by introducing carbon nanotubes into carbon fiber region. Introduction of nanotechnology in sports equipment makes bicycle lighter and stronger, and in turn helps cyclists to make a greater difference in cycling. A number of nanomaterials are used in sports, and so as a summary we will discuss the carbon nanotubes are used in tennis, badminton and golf, and what are the benefits that it will increase stiffness, consistency, resiliency and vibration control of the rackets. It will reduce weight and lower the torque. Carbon nanoparticles are used in road racing, and it will decrease the rolling resistance, increase grip and mileage in tires that they can travel over a longer distance in a few minutes. And the carbon nanofibers that are used in cycling will reduce weight and increase the stiffness of the bicycles. Fluorines are also used in tennis, badminton and bowling. It will also reduce the weight and twisting of racket frames and will reduce the chipping and the cracking of the balls. Nanoclays are used in watercraft and tennis. In watercraft, it will reduce weight and enhance the speed of the water boards, and in tennis, it will increase the bounce of the ball. Nanonickel is used in sport of golf, and it will increase the moment of inertia and stability of the clubs. Nanotitanium is used in badminton, and it will transmit more power to shuttlecock or ball and more accurate shots. Now, Nimra Sajid will discuss its further application of nanotechnology in automobile industry.
This is Nimra Sajid and I am going to discuss the applications of nanotechnology in automobile industry. So first the question arises that what is the use of nanotechnology in automobile industries? The answer is simple. It ensures the production of body parts with lighter weight and which are also very strong. It also ensures less fuel consumption. It enhances the safety of automobiles and the better performance of cars over a longer period. Okay, so first is the use of nanotechnology to produce lightweight automobile body parts. As we know, the carbon nanotubes, nanomaterials like titanium dioxide, magnesium, silicon, nanocomposites, they have light weight, so their application in the automobile body parts will reduce the weight, and it also increases the strength. As carbon nanotubes are used, so it increases the strength, and as the body weight decreases, it ensures the less fuel consumption. Another advantage is that multifunctional coatings are used to recast the steel at high temperature. So what is the use of steel? High strength steel is used to increase the strength of the body parts, and it is difficult to recast the steel at cold conditions. That's why this steel must have heated at high temperature in order to recast it. And the multifunctional coatings, which are made up of aluminum particles and nano size vitreous materials, these enhances this recasting process. Another advantage of nanotechnology is the production of safe mirrors and windows. As we know, during the daytime the sunlight, and in the night the light of other automobiles produces a glare on the glasses and mirrors of automobiles. So these mirrors are coated with aluminum oxide layers with thickness below 100 nanometer. These coatings are applied through a process of chemical vapor deposition. This not only reduces the glare of the light, but also ensures the safety and security, and provides the mirror with hydrophobic. Are the nanomaterial based ties? So the performance of tie depends on the cover composition of the tie. So if we add the nanoparticles in the rubber composite of tie, it increases the durability of tie. As the addition of nano aluminum trioxide, it enhances the wear resistance of tie. And a study reported that the nano alumina with the carbon black, it improves the wear resistance by up to 800%. Next are the nano based coatings. So coatings are the materials which protect the surface, which protect the body of a car. If we add the nanoparticles in the coatings and made the nanoparticle based coating, it enhances the protection and also gives a scratch resistance to the automobile bodies. It also protects the underneath layers from the weather conditions. It decreases the crack development by acting as a fillers in the pores of coating, and it also gives a self-healing ability to the coating. The example is the addition of nano silica, titanium dioxide, aluminum trioxide, zinc oxide nanoparticles as an additive in the coating. Okay, so this graph shows the wear resistance ability of modified and unmodified modified epoxy polyurethane coating with a nanomaterial. So when when there is an unmodified coating, its wear resistance is low as compared to the coatings which are modified with nano alumina and nano silica. As you can see from the graph, that when we add the nanomaterials in the coating, the wear resistance of the coating increases, so it will protect the body part from crack development and from corrosion. Is the application of nanotechnology for an efficient engine. So the coating of aluminium nanoparticles, it will reduce the friction of the cylinder walls. It will increase the heat exchange efficiency of the engine. As we add the silver nanoparticles in the diesel fuel, it will pure the diesel fuel. It will reduce the emission of toxic gases. Also the aluminium nanoparticles, when these are mixed with diesel fuel, these reduces the smoke concentration. The use of nanofluids, it increases the heat exchange ability of the engine. As this graph shows, that as we increases the concentration of aluminum trioxide, which acts as a nanofluid, when we increase the percentage of aluminum trioxide in the nanofluid, it will increases the heat exchange efficiency of the engine. The last application of nanotechnology is to provide safer indoor vehicle environment. In order to create the healthier environment, eco-friendly nano agents are used, like gold and silver nanoparticles. These are used because these have antimicrobial properties. In order to improve the interior air quality, filters are used which are covered with nanofibers, which improves the air quality inside the vehicle. Also some nanomaterials have the flame retardant agent property. They act as a flame retardant agents to reduce the fire chances in case of an accident. For example, carbon nanotubes, it can used as a filler in the automobile fabrics as a flame retardant agent.
Assalamu alaikum, this is me Javeria Wadood and I'm going to present about the nanotechnology and its application in space and science. Next is the application of a space flight and nanotechnology. Nanotechnology helps in making space flight more practical and could reduce the weight of a spacecraft by providing a lightweight skin and also maintaining and increasing structural strength. These helps in significantly reducing the amount of rocket fuel required, lowering the cost of reaching orbit and traveling in space. Similarly, nanotechnology can be used in a wide range of space industry including satellites, nanosensors, propulsion systems, rocket fuel, and spacecraft. Next is basically how multi-wall CNT's resin composite are applied in making the structures of satellites. We know that satellites in space has to operate in sphere environment. Due to the presence of intense ultraviolet and ionizing radiations, it is important to protect the outer surfaces of the satellites so that their efficiency could be improved. In order to overcome these problems, multi-wall CNT's resin composites provide lightweight, mechanically strong, and electrically conductive structures. And because of these properties, satellites shows reliable and uninterrupted performances in space. In comparison to these, multi-wall CNT's resin composites has their capacities to reduce electromagnetic interferences and therefore and because of these capacities they are utilized as reflectors. Next is a polymer-based nanocomposite as a thermal stabilizer. Polyhedral oligomeric silicioxane nanoparticles, which are also known as organic and inorganic hybrid material, as a nanosilica, are used as a nanofiller in different parts of the spacecraft. Because of their high thermal stability and high mechanical characteristics, these nanocomposites are utilized as flame retardants and chemical resistance in thermal protection system of rocket combustion chambers. And because of their ability to resist atomic oxygen in low Earth orbit, they are used as a protective layer on the satellite surfaces so that the satellite surfaces could remain intact. Next is polymer nanocomposite ablative material for re-entry vehicle. Ablative material is designed to slowly burn away in a controlled manner so that heat can be removed from the spacecraft by the formation of gases, and similarly the remaining solid material insulate the spacecraft from the superheated gases. So ablative materials are used as heat shields for the spacecraft. Otherwise, the mechanical parts would be damaged by the extremely high temperature while entering into the Earth atmosphere from spaces. For this purpose, polymer layer silicate nanocomposite show flammability resistance and are utilized in thermal protection systems. And because of their ability to use as a heat shield, they show high resistance to oxidation and mechanical erosion as compared to the composite ablative material. Effect of metal nanopowders on the performance of solid rocket propellants. Different type of nanometal particles such as zirconium, titanium and nickel are used in solid rocket propellants to increase their density, and because of it produces high energy. They not only promote their combustion but also increases the burning rate, and in comparison to metal bulk, they decreases the diffusion length. Because of the smaller sizes, they can travel more easily and more fastly as compared to the larger particles of the metal, and due to this it shortens the ignition time. Similarly, due to small size particles of the nanopowders, they attempts to form less agglomerate near the surface zone area where combustion occurs.
Assalamu alaikum. I'm Marij. I'm going to discuss applications of nanoparticles in aerospace industry. The aerospace industry, which is also known as defense industry, is one of the most important heavy industries in the world. For acquiring the best aircraft performance, it is necessary to find an aircraft design that increases the efficiency. This method includes the use of nanoparticles. Nanostructure science and technology is a broad and interdisciplinary area of research. It is also a critical enabling technology for modern aviation and large-scale power generation processes. Firstly, I am going to discuss application of aluminum nanoparticles in aerospace industry. The aerospace industry is increasingly considering the use of aluminum nanoparticles because of the remarkable properties they have. Aluminum nanoparticles can enhance the properties of the material by dispersing in them, like aluminum nanoparticles when mixes in fuel, which is used in aircraft applications. This fuel is not only used as a propellant but also used as a coolant. Also, the nanoparticles improves the thermal conductivity and combustion enthalpy of the fuel and reduces the friction between the parts of the engine. Now, use of aluminum oxide nanoparticles in a craft frame. The nanoparticles of aluminum oxide are hard and spherical material which are having high stiffness and high thermal conductivity, which improves the thermal and mechanical properties of the material which is used. Aluminum nanoparticles have thermal and electric conductivities, that is about they contain 60% of copper, which accounts for its development as a conductor in the form of bars and tubes, which are used in numerous electrical applications in aircraft. It reacts with oxygen in the air to form an extremely thin layer of oxide, which provides excellent corrosion protection properties. This layer is having the ability of self-repairing in case of damage. Also, anodizing process increases the thickness of the oxide layer and thus improves the strength of the natural corrosion protection process. Aluminum nanoparticles can be recycled indefinitely without losing any of their intrinsic qualities. They also have other applications, like they are hard and they are wear resistant. They show excellent dielectric properties. They have high strength and high stiffness, and they show excellent size and shape capability. Now I'm going to discuss Applications of graphene nanoparticles in aerospace industry. The excellent thermal properties of graphene have compelled a collaboration between Graphene's flagship and the European Space Agency for testing graphene for two different space-related applications, which has shown very promising results in improving the performance of loop heat pipes, thermal management systems used in aerospace and satellite applications. Graphene. Graphene is a two-dimensional material that has the potential to improve the aircraft performance, cost, and fuel efficiency. Graphene is a potential nanofiller when it is used as a polymer based composite. Even at very low loading, it dramatically improves the properties of the material, such as it improves the tensile strength and elastic modulus, also electrical and thermal conductivity of the material which is used. Ray Giblis, who was the CEO of Ideal Technologies, he has mentioned that using graphene, they have developed electrically conductive epoxy reagents, which can significantly increase the electrical conductivity of the carbon composite materials, which are used in the defense industry in the construction of fuselages to such a level that it would hopefully negate the use of copper mesh, which is employed for the prevention of damage caused from lightning strikes. It's essential to have a good conductor. Copper mesh is currently used in the body of the aircraft. Many composite materials used in aircraft, such as trays, overhead storage lockers, toilet fixers, etc., could all be made from graphene composite materials, and they are reducing weight, which is the constant goal of the aircraft industry without compromising on safety. Last but not least, graphene polymer composites are being tried for various potential applications due to their outstanding properties. Graphene aerogel is basically a porous structure which can be used for the manufacture of the aircraft industry, which will increase the specific fuel consumption, range, endurance, and performance of the aircraft. Thank you. That's all from my side.
Nanoparticles in aerospace engine parts, presented by Huria Absar. Next is supercapacitors. Supercapacitors for airplanes are ceramic, barium titanate, and barium strontium titanate. They are nano-electromechanical systems to develop a standard fuel management units for fuel control in aero engines. Next is gasket and sealant. Gaskets are basically glues which are used to join different parts of the planes. It is made up of nanographite and nanosilica in rubber compounds, inhibiting corrosion of aerostructure. Nanochromium-based corrosion inhibitors are being developed to use in aircraft protection. Next is conductive plastics. These are used in various components of the aircraft where electrostatic discharge of electromagnetic interferences shielding applications are required. They are powders of copper and iron. Parachutes and aircraft arrestor textiles. They are made up of nanofibers. Nanofibers polymers are utilized in making the parachutes and aircraft arrestor textiles. Aircraft electrocommunication system. The need for miniaturization of the components and devices has taken center stage of research in the field of nanotechnology. Especially the quantum effect of the wave-like behavior of the electrons started to look into the design functionality of the devices. Some have predicted that the silicon technology is approaching its fundamental limits, hence miniaturizing the design for a data storage unit started with a demand to compress storage in smaller spaces while keeping the energy demand low. To meet these standards, nanotechnology has entered in the area of miniaturized, faster and energy-saving communication system. Next is the metal oxide particles. They play a very important role in data storage. Hard disk uses supermagnetic material for data recording. But there is supermagnetic limit where ambient thermal energy reverses the recorded magnetization. To combat these defect exchange magnetic materials are being developed. For this purpose, ferromagnetically coupled magnetic material with exchange bias properties. Thank you.